Essential question, what properties do similar figures have? Pause, rewind this video as needed if I'm going too fast or if you need something repeated. Properties of similar figures. Make sure you're writing everything you see here into your notes, including the diagrams. So a couple properties of similar figures that you need to know is that when we have, say, similar triangles, it doesn't have to be a triangle, all of the corresponding angles are going to be congruent. Congruent means same measure, equal, if you will. Corresponding means matching. So let's talk about corresponding angles. So you can see in these three triangles, the three different angles, right? They're all slightly different sizes, but they are similar. But you'll notice that the angle is the same in each of those locations. Angle Y, same thing with angle X and angle Z. The angle measures don't change. If this is 40 degrees, then this is 40 degrees, and this is 40 degrees, and so on. Corresponding side lengths are proportional. That's the second thing that you need to know. Okay, so the side lengths are not the same, obviously, because you can have a larger triangle and a smaller triangle, and they're similar, right? So the side lengths are not going to be the same. But all of the different side lengths are proportional to one another, the ones that they correspond with. So that's what these proportions are essentially saying here. Side A corresponds to side D, so A and D, B to E, so B over E, and C to F. That's what this first proportion says. And they're all equal in proportion to one another. The same thing for the second part of the proportion here. All it's doing is just matching up these two triangles as well. A corresponds to P, B to Q, and C to R. Those side lengths, and they are all in proportion to one another. They have an equal proportional rate to each other. So those are the two properties of similar figures that you need to know. Angle measures that correspond do not change, and all of the side lengths that are corresponding are proportional. So let's look at this first example, number 1. It says right here, if triangle EFG, this means similar, that's simple, to triangle STR, then we're going to first find all of the angle measurements. So remember, these two triangles are similar to one another. That's what this statement is saying. The angle measures that correspond are going to be congruent. They're going to be the same measurement. Notice the order of the statement. It really matters. So triangle EFG is similar to triangle STR. So that means point E corresponds with point S, and F with T, and G with R. So if I go look at, say, angle G, for that matter, right here, right? Angle G is going to correspond with angle R in the other triangle. So if this is 50 degrees, that means that angle R is 50 degrees as well. So I'm going to write that in, 50 degrees. Well, and then, so it says find all angle measurements. So we're missing 2 here, but now I'm only missing 1 in this triangle here. So remember, all 3 angles on inside of a triangle add up to be 180 degrees. So if I know 2 of them, that means that I can find the missing third one. So if I add 50 plus 25 together, that's 75. And I'm just going to subtract that from 180 to find that missing third angle. So that's going to be 105 degrees. So now let's match up these angles. So angle T corresponds with angle F. So angle F will be 105 degrees, and then angle S corresponds with angle E. So that's going to be 25 degrees. And we found all the angle measurements. Find all the sides that correspond to one another. Okay, so now I'm going to erase this just to kind of give us some space. So first I'm going to write a similarity statement. So first I'm going to write that side EF, notice here, right, side EF corresponds with ST. So I'm going to write EF over ST is equal to FG over TR. All I'm doing is corresponding the different side lengths, and EG corresponds with SR. And I can see that straight from the similarity statement, just looking at the order of the statement. So now what we're going to do is we're going to find two side lengths that we already know. So EF is a side length that we already know. Notice how it corresponds with ST. So notice how we know those two side lengths. So I can just substitute 30 for EF and 12 for ST. And that is a ratio that we can use. All of the other side lengths, the corresponding side lengths, will be in the same exact ratio, the same proportion. So let's use that to find, for example, EG. So let's label EGX here. And we're going to use, notice how we know SR, right? So that's why we're going to solve for that one. So I'm going to say 30 over 12, because that's the ratio, our original ratio that we found, will be equal to, now it's going to be equal to this one here, EG over SR, right? So EG is X, because that's just what we labeled it, and SR is 15. So notice now that we've done that, we're going to solve this by cross multiplying, like you've been taught. So 12 times X is 12X, and then 30 times 15 is 450. And then we're just going to divide by 12 on both sides to find that missing side length. So let's see what 450 divided by 12 is. 450 divided by 12, and that would give me 37.5. So we can then say EG is equal to 37.5 inches. And that's how you would find any missing side length that it asks you to find. And we already did that for C right there. Okay, so we're good. So if you wanted to find another side length, like say RT, or for that matter, you could do that. Example 2, again, make sure that you have the diagram, and let's go ahead and answer these questions. So pause and rewind if needed. So it's saying, assume that DEFG is similar to ZXYW. Which side corresponds with XY? So I don't even need to look in the figure to even answer this question. If I just look right here, XY is right there. So therefore, EF corresponds with XY, EF in the other figure. Now it says, what is the measurement of XY? So if I go over here to the figure XY, I'm just going to label that side length X, because we're going to solve for it. So let's find two side lengths that correspond with one another. So let's see, let's start with DE, for example, first. Let me erase this. Here's DE. DE corresponds with ZX. So you can see we don't know DE as a side length, so I don't want to use that one. Let's go to EF. We definitely know EF. So if I look at EF, it corresponds with XY, so we don't want to use that one. Let's go look at FG or GF. Notice how that's 28. So what does that correspond with? That's going to correspond with YW. And we know that, look, YW is 18. So we can match those up and create a ratio. So 28 over 18 is the ratio that we want to use to solve. So I'm going to say 28 over 18 equals, and then we're going to say XY corresponds with EF, right? So I'm going to say EF over XY. It has to stay in that same order, right? 28 over 18 equals EF over XY. We know that EF is 18, so I can substitute that in for that, and XY, we just labeled it X. And then we're going to cross multiply and solve. So 28 times X is 28X, and 18 times 18, there, that's going to give us 324, and then we're just going to divide by 28 to solve for that missing side length. And we get 18, of course. So X equals 18, or we want to say XY equals 18, and we say 18 centimeters. In the last question here, it's asking us to find the measurement of GD. Let me zoom out a little bit. So GD is right here. Let's label that one Y. We're going to solve for that one. And we're going to use the same ratio. Remember, we already have that original ratio, 28 over 18, right? So I'm going to say 28 over 18 again. I can use this to find any side length. Equals, okay, and then I'm going to say Y, and then what does GD correspond with? If I just look up here in the statement, see DG or GD is going to correspond with ZW or WZ. And I can see over here that WZ is 14. So I'm going to say y over 14. And again, we're going to solve by cross multiplying. So 18 times y, 18y, 14 times 28, and then we'll divide that. So let's see, 14 times 28 gives me 392, and then I have to divide it by 18. And that's going to give us, we can round that to 21.8. So that's going to give us 392 divided by 18, and that gives us GD is equal to 21.8 centimeters. Last example here. Again, make sure this is in your notes as well. We have two triangles that are similar to one another, and we can see that here is our similarity statement. So that's really important. And it says find the measure of angle N. Okay, so what point, so if I could see angle N is in this triangle here, so angle R is going to correspond with it. So if I go over here, I see angle R is 79 degrees. Well, that means that angle N is 79 degrees. So I can do that. What you also could have done is notice that you have two angles on the inside of the triangle, so you just have to add them together and subtract from 180, and that would have given you 79 as well. You can see that, so 79, and then it says angle L. So I think we're going to do that here, right? We can just add these together or subtract from 180, or notice that what? This is 79 and 70. This is 79 and 70. Well, that's 31, right? So that has to correspond with L, which it does. So I'm going to say 31 degrees. Question C, what's the scale factor? Well, I just need to find two sides that correspond with one another. So let's start with MN. Do we know MN? We do not. So let's go to the next side. What about NO? Do we know side NO? We do. It's 8. What side corresponds with NO in the other triangle? RL does. What's RL? 40, right? So that means that NO and RL correspond to one another. So it's 8 over 40. So that's your scale factor, 8 over 40. Of course, we're going to reduce that. Let's divide it both by 8, both the top and the bottom by 8, and that's going to give us 1 over 5. So our scale factor is 1 over 5, or you could say 5 over 1, depending if you're talking about the smaller or the larger triangle. So I'm just going to write 1/5 as my scale factor, or you could say 5 over 1. Finally, we're going to use that scale factor to find the measurement of side MN. So MN is this one here. So I'm just going to label it X. And we're going to use the scale factor that we just found, 8 over 40, right? So I can say NO, side NO, over RL, that's the one we just found, right, is going to be equal to side MN over, and then let's look at our statement, right? MN is going to correspond with QR. So QR, you can see here, is 15. But for right now, I'm going to write QR, and now we'll substitute. So NO over RL is 8 over 40, and that equals MN, which is X. That's what we labeled X. That's what we're solving for. And QR is 15. And again, we're going to solve by cross multiplying. So 40 times X is 40X. 15 times 8 is going to be 120. And we're going to divide both sides by 40. And it looks like X equals 3. And then we want to just say MN, right? Because that's just what we labeled it, X. So MN equals 3. And then we don't have units, so we can just say units for this one. And again, that's using a scale factor that we found, 8 over 40, right? And using that to set up a proportion to solve for a missing side. Okay. That is our notes for today on corresponding parts and using corresponding parts and angles and side lengths to solve for missing angles and side lengths. So here's your summary. Explain the properties that similar figures have in a paragraph using complete sentences. Include your guys' own picture example in your summary. So make up your own picture example that illustrates what we're talking about in terms of these properties.